Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Welcome to the Microsoft Azure Virtual Training Day, Generative AI Fundamentals. My name is Alfonso Rodríguez Cotes, and I am from a wonderful island in Spain, Mallorca. I work here at Microsoft as Microsoft Technical Trainer, delivering courses about different topics like Azure, Microsoft's cloud, but especially those related to artificial intelligence. I am very happy to be able to be your partner in the amazing journey of learning about generative artificial intelligence. Sure, we'll learn and also enjoy a lot during these sessions. Actually, this course covers 3 sessions. The first one, session 1, is about to explore fundamentals of generative AI. Then we'll pass to session 2, where you will be introduced to the Azure OpenAI service. And finally, we'll wrap up the course with session 3, explore responsible generative AI. Let's start by defining artificial intelligence, or AI for short. We could say AI is like a virtual assistant that mimics human behaviors, learns from its environment, and also performs tasks without being explicitly told how to do so. Machine learning is a branch of artificial intelligence that involves the use of algorithms and statistical models to enable computers to improve a task as they gain more experience, essentially learning from data without being explicitly programmed. It's a powerful tool that can analyze large volumes of data, recognize patterns, and make predictions or decisions based on the inputs it receives. Generative AI, the topic we are focusing on in this course, is also a branch of machine learning and uses very complex deep neural networks behind the scenes. This fascinating technology has the capability to create new original content, whether it be in the form of written text, images, or even code, for example. Lately, generative AI has been taking center stage, especially in applications related to language processing. From helping craft persuasive speeches to generating insightful articles, it's revolutionizing the way we interact with language on digital platforms. Its capacity to analyze and learn from vast arrays of data allows it to offer nuanced and contextually aware responses or content catering to a wide variety of needs and industries. As we delve deeper into this course, we will explore the immense potential and the transformative impact that generative AI holds in the evolving landscape of technology and communication. At the heart of this innovation are large language models. Now, you might be wondering, what exactly are these large language models or LLMs? Well, they are like the masterminds behind the operations, adept at understanding and processing human language, also known as natural language processing or NLP. Let's break down some of the wonderful things they can do. Imagine having a tool that can gauge the mood or sentiment of a piece of text. This is where LLMs come into play with their ability to analyze and classify text based on the emotions or sentiments conveyed in them. It's like having a little helper that can tell you the tone of a message at a glance. But that's not all. These models are also proficient in summarizing large bodies of text. Picture having to go through a long article or report, because an LLM can help you grasp the key points in no time, saving your precious time and effort. Moreover, these smart assistants can compare different text sources to find similarities in their meaning or semantics. This function can be immensely helpful in research and/or analysis, where comparing various documents for coherence and similarity is essential. Moreover, these smart assistants can compare different text sources to find similarities in their meaning or semantics. This function can be immensely helpful in research and analysis, where comparing various documents for coherence and similarity is essential. Last, but certainly not least, they have the fascinating ability to generate new content in a natural language format. They can assist you in drafting messages, writing articles, and even creating narratives, making the task of generating content both effortless and enjoyable. Machine learning models for natural language processing have evolved over many years. These new large language models are based on the transformer architecture, which builds on and extends some techniques that has been proven successful in modeling vocabularies to support NLP tasks, and in particular in generating and working language. Transformer models are trained with large volumes of text, enabling them to represent the semantic relationships between the words, and also use those relationships to determine probable sequences of text that make sense. Transformer models are trained with large volumes of text, enabling them to represent the semantic relationships between words and use those relationships to determine probable sequences of text that make sense. Transformer models with a large enough vocabulary are capable of generating language responses that are tough to distinguish from the human responses. The magic of these models is that they address one of the biggest challenges in the realm of NLP. They are capable of incorporating contextual information into their analysis. In a nutshell, transformer models architectures consist of two components or blocks: an encoder block that creates semantic representation of the training vocabulary, and a decoder block that generates new language sequences. While a complete explanation of every aspect of the transformer models are beyond the scope of this module, an explanation of some of the key elements in a transformer can help you get a sense for how they support generative AI. While a complete explanation of every aspect of transformer models is beyond the scope of this module, an explanation of some of the key elements in a transformer can help you get a sense of how they support generative AI. Tokenization in LLMs is the process of breaking down text into smaller pieces called tokens to facilitate numerical analysis by the machine. Essentially, it is a step that translates human language into a format, numbers, that the AI can understand and process. For the sake of simplicity, you can think of each distinct word in the training test as a token. Though in reality, tokens can be generated for partial words or combination of words and even punctuations. The first step in training a transformer model is to decompose the training text into tokens. In other words, identify each unique text value. As you continue to train the model, each new token in the training text is added to the vocabulary with appropriate token IDs. For example, if you see the sentence on the screen, I heard a dog bark loudly at a cat, we have associated a token with each of the words. For example, I is 1, heard is 2, A is 3, dog is 4, and so forth. With a sufficient large set of training text, a vocabulary of many thousands of tokens could be compiled. While it may be convenient to represent tokens as simple IDs, essentially creating an index for all the words in the vocabulary, they don't tell us anything about the meaning of the words or the relationships between them. To create a vocabulary that encapsulates semantic relationships between the tokens, we define contextual vectors known as embeddings. Vectors are multivalued numeric representations of information, for example, 10, 3, 2, for the word dog, in which each numeric element represents a particular attribute of the information. For language tokens, each element of a tokens vector represents some semantic attribute of the token. The specific categories for the elements of the vectors in a language model are determined during the training based on how commonly words are used together or in similar contexts. It can be useful to think of the elements in a token embedding vector as coordinates in the multidimensional space, so that each token occupies a specific location. The closer tokens are to one another along a particular dimension, the more semantically related they are. In other words, related words are grouped closer together. The locations of the tokens in the embedding space include some information about how closely the tokens are related to one another. In the previous example, we looked at one sentence. Now, imagine the sentence is part of a whole document. We have tokenized all the text, and now we map the relationship between tokens. For example, the token for dog is close to cat and also to bark. The tokens for cat and bark are close to meow. The token for skateboard is farther away from the other tokens. Before moving on to the next point, attention, please note that in the previous example, there were only 3 dimensions, but real language models have many more dimensions, hundreds or even thousands of them. That is one of the reasons why they are so powerful and are able to understand language so well. Now, let's talk about what, for me, is the crown jewel of transformer-based LLMs: attention. The attention mechanism in language models allows the system to focus on different parts of a sentence more dynamically, enhancing its ability to grasp the nuances of natural language, much like how we humans naturally pay more attention to certain words when trying to understand the meaning of a sentence. The encoder and decoder blocks in a transformer model include multiple layers that form the deep neural network for the model. We don't need to go into the detail of all these layers, but it's useful to consider one of the types of layers that is used in both blocks. Again, attention layers. Attention is a technique used to examine a sequence of text tokens and try to quantify the strength of the relationships between them. In particular, self-attention involves considering how other tokens around one particular token influence that token's meaning. In an encoder block, attention is used to examine each token in context and determine an appropriate encoding for its vector embeddings. The vector values are based on the relationship between the token and other tokens with which it frequently appears. This contextualized approach means that the same word might have multiple embeddings depending on the context in which it's used. For example, the bark of a tree means something different to I heard a dog bark. In a decoder block, attention layers are used to predict the next token in a sequence. For each token generated, the model has an attention layer that takes into account the sequence of tokens up to that point. The model considers which of the tokens are the most influential when considering what the next token should be. Remember that the attention layer is working with numeric vector representation of the tokens, not the actual text. In a decoder, the process starts with a sequence of tokens embeddings representing the text to be completed. During training, the goal is to predict the vector for the final token in the sequence based on the preceding tokens. The attention layer assigns a numeric weight to each token in the sequence so far. It uses that value to perform a calculation on the weighted vectors that produces an attention score that can be used to calculate a possible vector for the next token. In practice, a technique called multi-head attention uses different elements of the embedding to calculate multiple attention scores. A neural network is then used to evaluate all possible tokens to determine the most probable token with which to continue the sequence. The process continues iteratively for each token in the sequence, with the output sequence so far being used regressively as the input for the next iteration, essentially building the output one token at a time. The animation on the slide shows a simplified representation of how it works. In reality, the calculations performed by the attention layer are more complex, but the principles can be simplified as shown. A sequence of tokens embedding is fed into the attention layer. Each token is represented as a vector of numeric values. The goal in a decoder is to predict the next token in the sequence, which will also be a vector that aligns to an embeddings in the model's vocabulary. And third, the attention layer evaluates the sequence so far and assigns weights to each token to represent their relative influence on the next token. And fourth, the weights can be used to compute a new vector for the next token with an attention score. Multi-head attention uses different elements in the embeddings to calculate multiple alternative tokens. And finally, a fully connected neural network uses the scores in the calculated vectors to predict the most probable token from the entire vocabulary. Then, the predicted output is appended to the sequence so far, which is used as the input for the next iteration. In a nutshell, a transformer model such as GPT-4, for example, is designed to take in a text input, called a prompt, and generate a syntactically correct output, called a completion. In effect, the magic of the model is that it has the ability to string a coherent sentence together. This ability does not imply any knowledge or intelligence on the part of the model, just a large vocabulary and the ability to generate meaningful sequences of words. Now that we have a better understanding of the theory and architecture behind generative artificial intelligence and LLMs, let's focus on the services we can find at Microsoft. Let's start with Azure OpenAI Service, which brings together the best of the OpenAI's cutting-edge models and APIs with the security and scalability of the Azure Cloud Platform. Microsoft's partnership with OpenAI enables Azure OpenAI users to access the latest language models innovations like, for example, GPT-4 models that are the latest generation of generative pre-trained models, GPT, that can generate natural language and also code completions based on natural language prompts. Access to GPT-4 models is currently restricted. For access, existing Azure OpenAI customers can apply. GPT 3.5 models can generate natural language and code completions based on natural language prompts. In particular, GPT 3.5 Turbo models are optimized for chat-based interactions and work well in most of the generative AI scenarios. Embedding models convert text into numeric vectors and are useful in language analytic scenarios, such as comparing text sources for similarities. DALL-E models are used to generate images based on natural language prompts. Models differ by speed, cost, and how well they complete specific tasks. You can learn more about the differences in latest models offered in the Azure OpenAI Service documentation. The availability of large language models, LLMs, has paved the way for the development of innovative software tools, commonly known as copilots. These tools can be integrated into different applications, offering users assistance with routine tasks through the capabilities of a generative AI model. Built on a uniform architecture, developers have the latitude to craft specialized copilots to cater to diverse business-related applications and also services. It's not uncommon to encounter these copilots within already familiar products, perhaps manifested as a chat interface adjacent to your document, utilizing the content generated of search within the product to refine its output. Understanding the relationship between the inception of a LLM and the development of a copilot application can be elucidated as follows. A large amount of data is used to train a large language model. Services such as Azure OpenAI Service make pre-trained models available. Then developers can use these pre-trained models as they are or fine-tune them with custom data. Deploying a model makes it available for use in applications, and developers can build copilots that submit prompts to models and generate content for use in applications. Business users can use copilots to boost their productivity and also creativity with AI-generated content. In essence, copilots stand to significantly alter our work dynamics, assisting in the initial creation of documents, compiling information, aiding in strategic planning, and much more, all powered by generative AI technology. Microsoft has already added copilots to commonly used applications like the Edge browser, Bing search engine, and Microsoft 365 products like PowerPoint, Word, Excel, Outlook, etc., in order to increase productivity. And please, don't forget GitHub Copilot. GitHub Copilot, our code completion assistant that helps developers write new code and understand and work with existing code faster by suggesting whole lines of block of code as you type, helping to speed up the coding process and reduce the likelihood of errors. Now, let's move on to the final section of this session and discuss prompt engineering a bit. The quality of responses that a generative AI application returns not only depends on the model itself, but also on the types of prompts it's given. Prompts are ways we tell an application what we want to do. An engineer can add instructions for the program with prompts. For example, developers may build a generative AI application for teachers to create multiple choice questions related to the text a student read. During the development of the application, developers can add other rules for what the program should do with the prompts it receives. As you can see in the slide, there are some good practices that you should consider, like, for example, writing good prompts. You can achieve better results when you submit clear, specific prompts. Also, adding system messages to add context for the model by describing expectations and constraints. For example, you are a helpful assistant that responds in a cheerful, friendly manner. These system messages determine constraints and the styles for the model's responses. Also, provide examples. However, you can also provide one-shot learning prompts that include one or a few examples of the output you require, such as, for example, visit the castle in the morning before the crowds arrive. The model can then generate further responses in the same style as the examples provided in the prompt. Show the chat the type of responses you want. It will try to mimic any responses you add. And finally, grounding data. You can use grounding data as a prompt engineering technique to gain many of the benefits of fine-tuning without having to train a custom model. To apply this technique, include contextual data in the prompt so that the model can use it to generate an appropriate output. For example, suppose you want to use an LLM to generate a summary of an email. You can include the email text in the prompt with an instruction to summarize it. All right, now I think it's a good moment to get down to work and do a demo related to the content we have just covered. I mean, the use of generative AI, in this case, using Bing Chat Copilot. Okay, in order to have access to Bing Chat Copilot, first we need a personal Microsoft account, Hotmail, Outlook, or something. So, for example, in case you don't have one, you can directly go to signup.live.com and create one. Then you can see that I have already signed with a personal account here. And what we need to do is to click on this chat bubble, clicking on the bubble. And now we are already in the Bing Chat Copilot. The only thing we need to do is go here to this Ask Me Anything window and ask for a request, or better said, add a prompt. Now let's talk about a little bit about traveling. And what I'm going to do is to type a prompt saying, what are 3 pros and cons of traveling in the winter? And just clicking this arrow here, we can submit that prompt, or even clicking intro, we'll have an answer from the system. We can see that we have some pros like lower prices, fewer crowds, etc. And then also now is giving me some cons. The model uses the search for responses as grounded information to generate original responses. Notice, please, that at the end of the response, you can find the links to the sources. Here we can see those links. The links. So if I click in any of the links, it will drive me to that source or web where that content is displayed. Now we can continue the conversation. Remember, this is a chat. So in a kind of a human way of talking, again, like a conversation. And let me continue. And I'm going to ask the Bing Chat Copilot to please find me 3 more pros. Find me 3 more pros. And now is continuing giving me these results. Again, the important thing here is that we can have a conversation. Remember that traditional search engines are not able to keep a conversation and keep the context of the previous request. That is why this copilot, this complement is so useful. I guess now, let's continue. So I guess you have seen this new topic bubble here in the bottom left of the screen. This is to clear the previous conversation. So I'm clicking in this new topic option and everything has been cleared and we can start over with a new conversation. Now I'm going to show you how to do something that I believe is amazing, because this Bing Chat Copilot is not only for keeping conversations, for looking for information, because it is also able to generate things, to generate content, and also to generate images. So I'm going to type here an example of create an image of an elephant eating a hamburger. And after seconds, please notice that there is a message saying that I will try to create that. And after some seconds, sometimes could be a little longer. So now we can see several images of an elephant eating a hamburger. And just please notice that here we have this reminder that all these images has been powered or generated by a DALL-E model. Remember that we have already talked about the DALL-E models in this session. And we can start having a look into those images. We can share them, we can save, we can download them, etc. Now I'm going to show you one more amazing feature that we can find in this Bing Chat Copilot. In this case, it's about the use of code generation. I'm going to type in a prompt. That prompt is use Python. Python is a programming language to create a list. And you can see, after a few seconds, how it is creating me that list. Okay? This is an example of how to create code with this tool. But it has more capabilities. Like, for example, we can translate one code language to another. For example, I'm going to type in translate that or this code into C#. C# is also a programming language. And again, after seconds, we can see that is doing that translation for me. So it's translating this Python language it's converting it into this C# language. Amazing, isn't it? So before ending this demo, I have cleared the chat, and now I'm going to do a last request, or I'm going to add a last prompt. What are 3 examples of generative AI helping people? And now it will give me those 3 examples that, well, let's give me an explanation. But for example, conversational AI apps for patients, AI applications for early detection of certain diseases, and AI for accessibility. Amazing. We've covered a lot in this session. We started by defining generative AI. Then we continued with the explanation of large language models, LLMs. And then we explored the different solutions available, like Azure OpenAI Service or the copilots. Finally, we shared some good prompt practices related with prompt engineering. This concludes session 1. We will take a quick 10 minutes break and start back with session 2, Introduction to Azure OpenAI Service. Welcome to Session 2, Introduction to Azure OpenAI Service. Now, let's directly go to the second session of the course, in this case about the Azure OpenAI Service. Here is a snapshot of what you can expect from this session. We'll start with a very short recap about what generative AI is. From there, we'll dive into Azure OpenAI, and we'll give you a brief description of this powerhouse. I will also guide you through the steps on how to use Azure OpenAI. And as we move along, we'll explore the capabilities of Azure OpenAI, specifically regarding natural language processing, the magic behind its code generation abilities, and OpenAI's or Azure OpenAI's image generation features. And to run it off, we'll discuss the accessibility of Azure OpenAI, as well as touch upon its responsible AI policies to ensure we use it ethically and effectively. All right, let's get started with Session 2. We have already described generative AI. Just remember, we can develop applications by creating new original content and also being able to understand natural language. In this session, we are going to dive into how Azure OpenAI provides access to generative AI for developers. We have already introduced Azure OpenAI last session. As a reminder, we could say Azure OpenAI Service brings together the best of OpenAI's models and APIs with the security and scalability of the Azure Cloud Platform. Azure OpenAI Service is a result of the partnership between Microsoft and OpenAI. The service combines Azure's enterprise-grade capabilities with OpenAI's generative AI models capabilities. Azure OpenAI is available for Azure users and consists of 4 main components. First, pre-trained generative AI models like GPT 3.5 Turbo or GPT-4, also embedding models, or DALL-E for image generation, for example. Second, customization capabilities. Azure OpenAI Service lets us tailor our models to our personal datasets by using a process known as fine-tuning. This customization step let us get more out of the service by providing higher quality results than what you can get just from design, the ability to train on more examples that you can fit into a prompt, and lower latency requests. Third, Azure OpenAI Service provides built-in features to help ensure responsible use of AI models. These features include content filtering and abuse monitoring. And fourth, Azure OpenAI Service provides enterprise-grade security with role-based access control, RBAC, and private networks. RBAC allows you to manage access to Azure resources by assigning roles to users, groups, or even applications. Private networks provide a secure way to connect your Azure resources, allowing you to isolate your AI models and data from the public internet. Finally, there are various approaches to crafting Azure OpenAI solutions, including utilizing the Azure OpenAI Studio, leveraging the REST APIs, employing supported SDKs, or using the Azure CLI. Later, we'll run a demo about the Azure OpenAI Studio. But for now, let me introduce you this amazing tool. But first, one important note. Currently, you need to apply for access to Azure OpenAI by filling in a form. Once granted access, you can use the service by creating an Azure OpenAI resource. like you could do for other Azure services. Once the resource is created, you can use the service through REST APIs, Python SDKs, or the web-based interface in the Azure OpenAI Studio. Understanding how to utilize Azure OpenAI is key. Azure OpenAI Studio is your space to build and deploy AI models for software applications. In the Azure OpenAI Studio, you can build AI models and deploy them for public consumption in software applications, and also the Azure OpenAI capabilities are made possible by specific generative AI models. Different models are optimized for different tasks. Some models excel at summarization and providing general and structured responses, and others are built to generate code or unique images from a text input. As said, these Azure OpenAI models include GPT-4 models that represent the latest generative models for natural language and code, GPT 3.5 models that can generate natural language and code responses based on prompts too, embedding models that convert text to numeric vectors for analysis, and DALL-E models that generate images based on natural language descriptions. Within the Azure OpenAI Studio, you will also have the opportunity to experiment with the OpenAI models in Playgrounds, which offer a code-free environment for experimentation in a simple visual manner, with a plethora of examples and preset use cases. Later in the demo, you'll see in action how you can choose between the completions playground, where you can type in prompts, configure parameters, and see the responses without having to code, and also the chat completions playground, where you are going to be able to use the assistant setup to instruct the model about how it should behave. The assistant will try to mimic the responses you include in tone, rules, and format you have defined in your system message. As we have been mentioning before, generative pre-trained models, or generative pre-trained transformer models, GPT models, open up a world of possibilities both in terms of understanding and also generating natural language. This will enable us to create a multitude of solutions. We can choose to use these models for individual tasks, as said before, summarization, translating, analyzing sentiments, etc. In the left side of the screen, we can see an example of a prompt where the user types in text asking for a cooking recipe. In the right side of the screen, we can see how the model gives you an answer to that prompt and creates the recipe instructions for you. This is a simple example, but bear in mind that we can also develop applications that combine several of these options and much, much more. We can even combine different Azure AI services and put them to work together with these Azure OpenAI solutions, but that is out of the scope of this course. GPT models are able to take natural language or code snippets and translate them into code. The OpenAI GPT models are proficient in over a dozen languages, such as C#, JavaScript, Perl, PHP, and is most capable in Python. GPT models have been trained on both natural language and billions of lines of code from public repositories. The models are able to generate code from natural language instructions, such as code comments, and can suggest ways to complete code functions. So GPT models can help developers code faster, understand new coding languages, and focus on solving bigger problems in their applications. Developers can break down their goals into simpler tasks and use GPT to help build out those tasks using known patterns. Code generation goes beyond just writing code from natural language prompts. For example, we can see in the left part of the slide how, given just some incomplete code, the unit test in this example, it is able to generate the entire code. By the way, while we are on the topic of code, let me not forget to mention again GitHub Copilot. We saw in the last module how OpenAI partnered with GitHub to create GitHub Copilot, what is called the AI pair programmer. GitHub Copilot integrates the power of OpenAI Codex into a plugin for developer environments like, for example, Visual Studio Code. Once the plugin is installed and enabled, you can start writing your code, and GitHub Copilot starts automatically suggesting the reminder of the function based on code comments or the function name. GitHub Copilot offers multiple suggestions for code completion, which you can tap through using keyboard shortcuts. When given informative code comments, it can even suggest a function name along with the complete function code. In addition to natural language capabilities, generative AI models can edit and create images. The model that works with images is called DALL-E, much like GPT models. Subsequent versions of DALL-E are appended onto the name, such as DALL-E 2, for example. Image capabilities generally fall into the three categories of image creation: editing an image, and creating variations of an image. Original images can be generated by providing a text prompt of what you would like the image to be of. The more detailed the prompt, the more likely the model will provide a desired result. With DALL-E, you can even request an image in a particular style, such as a dog in the style of Vincent van Gogh. Styles can be used for edits and variations as well. For example, given the prompt an elephant standing with a burger on top, style digital art, the model generates digital art images depicting exactly what is asked for. Also, when provided an image, DALL-E can edit the image as requested by changing its style, adding or removing items, or generating new content to add. Edits are made by uploading the original image and specifying a transparent mask that indicates what area of the image must be edited. Along with the image and mask, a prompt indicating what is to be edited instructs the model to then generate the appropriate content to fill the area. And finally, we also have the possibility to get image variations that can be created by providing an image and specifying how many variations of the image you would like. The general content of the image will stay the same, but aspects will be adjusted, such as where subjects are located or looking, background scene, and colors may change. For example, if I upload one of the images of the elephant wearing a burger as a hat, I get variations of the same subject, like you can see on the slide. Okay, we have finished the content of this session, so it is a good time to run a demo about the Azure OpenAI service and see how to deploy a model and try some of the main features like the chat playground. Okay, so you can see I am inside my Azure portal, and in order to go to the Azure OpenAI service. But before that, please remember that you will need an Azure subscription that has been approved for access to the Azure OpenAI service for both text and code models and also DALL-E image generation models. So you can get a free subscription going to azure.microsoft.com. You scroll down a little bit, you can see this start free option. Clicking on here, you can create a free account with different options for you. Like, for example, you'll have some popular services free for 12 months, and also 55 other services that will be always free. But the most important thing is that you can start with a $200 credit that you can spend in Azure. This is for getting the subscription, but remember that you also need to request access to the Azure OpenAI service, filling in a form like this one. Okay? Cool. So let's come back to the Azure portal, and let's go to the Azure OpenAI service. There are always different ways to get to the same place in Azure. For example, what I'm doing here is to click Azure AI. If I click Azure, if I type in Azure AI in this search tab, here you can see the Azure AI services. I'm going to click in this Azure AI services option, and the very first option available is Azure OpenAI account. In this case, what we're going to do is to create the Azure OpenAI resource by clicking here on Create. And now I need to make some decisions. Like, for example, the first thing I need to do is to choose a subscription. Again, a subscription with access to the Azure OpenAI service. Remember that we need to ask for or request access before. Here is my subscription, and now I need to decide where this resource is going to be placed. For example, we can decide to choose one of the resources that the resource group that we already have, or to create one. In my case, I'm going to create a new resource group. Resource groups are like a containers that holds the associated resources to a solution. I'm going to name it demo. Then I need to choose a region. Please bear in mind that not all the regions have the same capabilities, but for this demo, I think East US is going to be okay. And then I need to put a name to my resource. Again, to this Azure OpenAI resource. And in this case, I'm going to choose Demo Generative. Okay? Demo Generative. And then, finally, I need to select a pricing tier. In this case, it's super easy because there is only one option. So we don't have free tier here, so we need to always choose this standard pricing tier option. Then we can also select more configurations, like, for example, that related with networking. So remember that one of the main advantages in Azure is that we have the possibility to isolate our solutions, to manage security, to manage networking, etc. But for now, I'm going to leave it like it is. And also we can add tags to our resources, but I'm going to click next, and everything is okay. And finally, I'm going to click on Create to create this Azure OpenAI resource. You'll see that you will need to wait some time in order to be deployed. So maybe could take like a minute or so, more or less. Okay, cool. So now we can see that the deployment is complete. So it has been successful. We can now access to the resource. So I'm going to click on here in Go to Resource. And here I have my demo generative resource. This is an OpenAI for my OpenAI service. And from here, I can do a lot of things, like, for example, adding role-based access control, manage keys and endpoints, networking, identity, and much, much more that is out of the scope of this demo. But what I wanted to show you now is how to go to the Azure OpenAI Studio, where I'm going to start deploying the models. So please, it's important you to understand that what we have done is to deploy a resource, but now we will need to deploy the models, the GPT models. In order to do that, I'm going to click here on Go to Azure OpenAI Studio. We can do the same just clicking on Explore, but I'm choosing this way. Remember, I said that before, we have different ways to get to the same places in Azure. And voila, here is my Azure OpenAI Studio for that resource. And now here is where we can start deploying models and start playing with the chat playground, completions, or generating images, for example. But what I'm going to do now is to have a look into the models that are available in that region. So you can see that we have a lot of GPT models available, like, for example, GPT 3.5 Turbo or text embeddings, or etc. Okay? And now what I'm going to do is to deploy a model. Why? Because I'm going to click here in chat, for example, now, but I cannot start using this chat playground because I don't have a model deployed yet. So again, the first thing I need to do is to deploy a model. I'm going to click here in deployments. And what I'm going to do is to create a new deployment. I'm clicking here on Create New Deployment. And I'm going to select a model. For this case, I'm going to choose GPT 3.5 Turbo. And the model version is okay, up to date, to default. But I need to add a name to my model. So in this case, I'm going to use something that I can remember later. So I'm going to put here 3.5 Turbo Chat, for example, 3.5 Turbo Chat, and then click on Create. After a few seconds, I can see that the deployment has been successful. So in here I have my GPT 3.5 Turbo model already deployed, and now I can start using it in the different playgrounds. For this demo, what I'm going to do is to go to the chat playground. If I click on chat playground, here is the main screen. Please be aware that depending on the resolution of your screen, you have like a different layer. So if I put the resolution a little down, so this is the screen. So here we have the assistant setup, the chat session, and configuration. But again, I'm going to zoom it a little bit in order to make it easier for you to read it. So, and now we can see that the assistant setup is on the top, and then we have the chat session, and then the configuration. Okay. If I scroll down again to my configuration, I can see the model that is using this chat playground right now is the model I have just deployed, this 3.5 Turbo Chat model, which have GPT Turbo behind the scenes. And now let's start playing a little bit. The cool thing here is that we can add what is called a system message. A system message, remember from the session before, is a way to ask the chat to behave in the way we prefer. This is the default system message, like you are an AI assistant that helps people find information, but we can also change it. We can change it or directly select some examples in order to see how it is behaving. Like, for example, Xbox customer support agent. If I click on here, so this is the message now. This is the system message that is going to provide context to the model. And also we can even add examples of prompts, of questions, and also the answers of the assistant. Okay? But for this demo, let's choose again the default system message, which is, you are an AI assistant that helps people find information. And now if I scroll down, I can start using the chat. In this example, I'm going to ask a question. What is generative AI? I'm going to submit my prompt. And here you can see the answer. Which is a definition of generative AI. But now we can start keeping that conversation, so we can start like talking and continue asking questions about the same topic, for example. So here the system is mentioning neural networks. So I can ask, for example, and what are neural networks? And again, we are having this conversation. The good thing here is the chat session has kept track of the previous input and response to provide context in the second answer. And we can adjust more parameters just clicking here in this tab, parameters, and we can see that we have different options like adjusting the max response tokens allow. So here you can see that they have up to 800 tokens allow in the response, and also we can have more parameters that are out of the scope of this training. Okay, finally, let's go to a new tab. This is the DALL-E option. And in addition to language generation models, remember that Azure OpenAI Service supports the DALL-E 2 model for image generation. And just clicking here in this DALL-E tab, we can start creating, and not only creating, but also working with our images. For example, I'm going to add a prompt here, which is a robot eating spaghetti. And after a second, we can see how the model has generated different images of a robot eating spaghetti. But the cool thing, as I told you before in the session, is that we can also add styles in our images. So, for example, I'm going to generate a new image with the same prompt, a robot eating spaghetti. But in this case, I'm going to ask the model to deliver that to me in the style of Rembrandt. If I click on here, we can see this image of a robot eating spaghetti in the style of Rembrandt. Okay, cool. So this is all. So we have reviewed how to create an Azure resource, an Azure OpenAI resource, how to deploy a GPT model, and also how to work with the chat and also the image generation features. Great, we have finished session 2. We started with a brief recap about generative AI. Then we have explored the Azure OpenAI service and how to use it in order to develop solutions related with natural language, but also with code and image generation. And finally, we ended with the responsible AI practices. Okay, this concludes session 2. Thank you for your time. Welcome back from the break. Now, let's explore responsible generative AI. In this session, we'll learn how to plan a responsible generative AI solution. Remember, generative AI is one of the most powerful advances in technology ever. That is why developers and others involved in creating generative AI solutions must adopt a responsible approach that identifies, measures, and mitigates risks. So we'll go in detail on all those stages. And finally, we'll talk about how to operate a responsible generative AI solution. At Microsoft, we hold the principles of responsibility and privacy in the highest regard. It's imperative to emphasize that this is not just another aspect to consider. It fundamentally stands at the core of every service we launch. Right from the inception, these principles are intricately woven into the fabric of our products and services. We have already seen that generative AI is one of the most powerful advances in technology ever. It enables developers to build applications that consume machine learning models trained with a large volume of data from across the internet to generate new content that could not be differentiated from content created by a human. With such powerful capabilities, generative AI also brings some concerns and requires that data scientists, developers, and others involved in creating generative AI solutions adopt a responsible approach that identifies, measures, and mitigates risks. The Microsoft guidance for responsible generative AI is designed to be practical and actionable. It defines a 4-stage process to develop and implement a plan for responsible AI when using generative models. Initially, it is vital to identify the potential harms that could stem from your planned solution. Being vigilant at this phase helps in framing appropriate safety nets as we move forward. Next, we emphasize measuring the presence of these identified harms in the outputs generated by your solution. This step involves meticulous scrutiny to prevent adverse outcomes effectively. Following this, we focus on mitigating these harms at multiple layers within your solution. This approach not only minimizes their presence and impact, but also accentuates transparent communication about potential risks to users, fostering trust and reliability. Lastly, we advocate for responsible operation of the solution, which involve a well-defined deployment and operational readiness plan, ensuring the solution's seamless and responsible integration into the existing ecosystem. It's noteworthy that these stages resonate profoundly with the principles embedded in the NIST AI Risk Management Framework, making this guide a synergized approach towards responsible AI development. Now, let's delve deeply into each of these stages, offering actionable insights and suggestions to foster the development of successful and responsible generative AI solutions. This approach ensures that we not only harness the potential of AI, but do so in a manner that is ethical and considers potential risks and pitfalls. As said, let's go deeper now into the first stage, identifying potential harms. To do this, we are going to break it down into 4 steps. The first is actually identifying potential harms. The potential harms that are relevant to your generative AI solution depend on multiple factors, including the specific services and models used to generate outputs, as well as any fine-tuning or grounding data used to customize the outputs. Some common types of potential harms in generative AI solutions may include generating content that is offensive, pejorative, or discriminatory, generating content that contains factual inaccuracies, generating content that encourages or supports illegal or unethical behaviors or practices. Please consider reviewing the guidance in the Microsoft Responsible AI Impact Assessment Guide and using the associated Responsible AI Impact Assessment template to document potential harms. The second step is prioritize those identified harms. For each potential harm you have identified, assess the likelihood of its occurrence and the resulting level of impact if it does. Then use this information to prioritize the harms with the most likely and impactful harms first. This prioritization will enable you to focus on findings and mitigating the most harmful risks in your solution. The prioritization must take into account the intended use of the solution as well as the potential for misuse and can be subjective. Then we'll continue to the third step, test and verify the prioritized harms. Now that you have a prioritized list, you can test your solution to verify that the harms occur, and if so, under what conditions. Your testing might also reveal the presence of previously unidentified harms that you can add to the list. A common approach to testing for potential harms or vulnerabilities in a software solution is to use red teams, in which a team of testers deliberately probes the solution for weaknesses and attempts to produce harmful results. Lastly, we conclude this stage with document and share the verified harms. When you have gathered evidence to support the presence of potential harms in the solution, document the details and share them with the stakeholders. The prioritized list of harms should then be maintained and added if a new harm is identified. Now let's move on to the second stage. After compiling a prioritized list of potential harmful outputs, you can test the solution to measure the presence and impact of harms. Your goal is to create an initial baseline that quantifies the harms produced by your solution in given usage scenarios, and then track the improvements against the baseline as you make iterative changes in the solution to mitigate the harms. A generalized approach to measuring a system for potential harms consists of 3 steps. First, prepare a diverse selection of input prompts that are likely to result in each potential harm that you have documented for the system. Second, submit the prompts to the system and retrieve the generated output. And finally, third, apply predefined criteria to evaluate the output and categorize it according to the level of potential harm it contains. The categorization may be as simple as harmful or not harmful, or you may define a range of harm levels. After going through these first 3 steps, please let me give you a practical advice. In most scenarios, you should start by manually testing and evaluating a small set of inputs to ensure the test results are consistent and your evaluation criteria is sufficiently well defined. Then, devise a way to automate testing and measurement with a large volume of test cases. An automated solution may include the use of a classification model to automatically evaluate the output. Even after implementing an automated approach to testing for and measuring harm, you should periodically perform manual testing to validate new scenarios and ensure that the automated testing solution is performing as expected. After determining a baseline and a way to measure the harmful output generated by a solution, you can take steps to mitigate the potential harms, and when appropriate, retest the modified system and compare harm levels against the baseline. Mitigation of potential harms in a generative AI solution involves a layered approach in which mitigation techniques can be applied at each of 4 layers, as shown in the slide. The model layer is at the heart of your solution. For example, your solution might be built around a model such as GPT-4. Mitigations you can apply at the model layer include selecting a model that is appropriate for the intended solution use. For example, while GPT-4 may be a powerful and versatile model, in a solution that is required only to classify small specific text inputs, a simple model might provide the required functionality with lower risk of a harmful content generation. Fine-tuning a foundational model with your own training data so that the responses it generates are more likely to be relevant and scoped to your solution scenario. The safety system layer includes platform-level configurations and capabilities that help mitigate harm. For example, Azure OpenAI Service includes support for content filters that apply criteria to suppress prompts and responses based on classification of content into 4 severity levels: safe, low, medium, and high, for 4 categories of potential harm: hate, sexual, violence, and self-harm. Other safety system layer mitigations can include abuse detection algorithms to determine if the solution is being systematically abused, for example, through high volumes of automated requests from a bot, and alert notifications that enable a fast response to potential system abuse or harmful behaviors. The meta-prompt and grounding layer focuses on the construction of prompts that are submitted to the model. Harm mitigation techniques that you can apply at this layer may include specifying meta-prompts or system inputs that define behavioral parameters for the model, applying prompt engineering to add grounding data to input prompts, maximizing the likelihood of a relevant, non-harmful output. Using a retrieval augmented generation approach to retrieve contextual data from trusted data sources and include them in the prompts. The user experience layer includes the software application through which users interact with the generative AI model, as well as documentation or other user collateral that describes the use of the solution to its users and stakeholders. Designing the application user interface to constraints inputs to specific subjects or types, or applying input and output validation can mitigate the risk of potentially harmful responses. Documentation and other descriptions of a generative AI solution should be appropriately transparent about the capabilities and also the limitation of the system, the model on which it's based, and any potential harms that may not always be addressed by mitigation measures that you have put in place. We have already delved deeply into each of the stages of planning a responsible generative AI solution. Now, to conclude, let's explore how to operate that responsible generative AI solution. After you have found out the possible issues, establish a method on how to track them, and set up ways to lessen them in your solution, you are almost ready to launch your solution. But first, there are a few key things to think about to make sure the launch and feature steps are successful. Before releasing a generative AI solution, identifying the various compliance requirements in your organization and industry, and ensure the appropriate teams are given the opportunity to review the system and its documentation. Common compliance reviews may include legal, privacy, security, accessibility. Also, consider the guidelines shown in the slide. For example, devise a phased delivery plan that enables you to release the solution initially to a restricted group of users. This approach enables you to gather feedback and identify problems before releasing to a wider audience. Create an incident response plan that includes estimates of the time taken to respond to unanticipated incidents. Create a rollback plan that defines the steps to revert the solution to a previous state in the event of an incident. Implement the capability to immediately block harmful system responses when they are discovered. Implement a capability to block specific users, applications, or client IP addresses in the event of system issues. Implement a way for users to provide feedback and report issues. In particular, enable users to report generated content as inaccurate, incomplete, harmful, offensive, or otherwise problematic. Track telemetry data that enables you to determine user satisfaction and identify functional gaps or usability challenges. Telemetry collected should comply with privacy laws and your own organization's policies and commitments to user privacy. All right, I believe could be a good idea to run a demo now. During the session, we have talked about the importance of being responsible and avoid potential harms in our solutions. So let's see how we can apply content filters inside the Azure OpenAI service to avoid sexual, violence, or discriminatory answers from our models. All right, as you can see on the screen, I am already in Azure, and now I'm going to choose one of the Azure OpenAI resources that I have already created. In order to do that, I'm going to click on here in this Azure OpenAI icon. And now I'm going to choose this demo generative OpenAI resource that, again, I have already created. And in order to do this demo about the content filters, I need to go to my Azure OpenAI Studio. That's why I'm going to make click here. And here on the bottom, on the left bottom part of the screen, you can see this content filters option. But later we'll go into this, but now let me go to the chat playground. Just clicking here on this chat icon. What I'm going to do is to add a prompt, start a conversation, adding a prompt here in this window, and I'm going to ask to describe the characteristics of Scottish people. Okay, cool. So now we can see that we have a description with some characteristics of the Scottish people, always in the from the point of view of the chat. And we can see that, for example, they have a strong sense of national identity, or I don't know, there are people known for their love of music, dancing, and storytelling, etc. Okay, now what I'm going to do is to go to my system message. Again, these system messages are useful in order to ask context or even instructions to the model about how it should behave. And I'm asking the model to act as a racist. That is why I'm going to type in, I'm going to remove this system message. You are an AI assistant that helps people find information. And I'm going to add a new system message. You are a racist AI chatbot that makes derogative statements based on race and culture. Now, one important thing is to save these changes. Remember to do it, because if you don't do it, won't be applied. I'm going to save the changes. And it's giving me a warning, so I'm going to say continue. And now I have this system message. And what I'm going to do is to clear the chat. I'm going to clear the chat. And again, with this system message, you are a racist AI chatbot that makes derogative statements based on race and culture. I am going to add the same prompt as before. So I'm going to do the same request. Describe characteristics of Scottish people. And now we can see something that is that now is not able. And now we can see how the model is not going to provide me any information. It says, I'm sorry, I cannot fulfill that request as it goes against my programming to engage in discriminatory behavior based on race or culture, etc. Okay? So why is this happening? This is happening because behind the scenes, there are some content filters that are working in order to avoid this kind of behaviors. If we go to the Content Filters tab, here at the bottom left part of the screen, we can start configuring. We can start with the configuration of these content filters. These content filters are applied to prompts and completions to prevent potentially harmful or offensive language being generated, as we have seen before during the session. And if we click on here, create customized content filters, here in this screen, you can see how content filters are based on restrictions on 4 categories of potential harmful content. Okay, we can see these categories of hate, sexual, self-harm, or violence. If we can have more information about these categories just clicking on the eye icon. And now we can see how these filters, in this case, are applied, again, for these categories for prompts and completions, with a severity setting of safe, low, medium, or high. You can observe how, by default, the default settings allow the low severity language for each category. So low severity is allowed for hate, sexual, self-harm, violence in prompts, and also the same with completions. But filters are applied for medium or high severity in prompts and also in completions. We can create a more restrictive custom filter by applying filters to one or more low severity levels. For example, I can also apply a filter for low severity levels in hate in sexual, for example, in prompts and also in completions. Again, I can make my model more restrictive, but not the opposite. Always will be set, the filters always will apply for medium or high severity in prompts and outputs. So now that I have decided to my model to be more restrictive by applying also low severity filters for hate and sexual, I can save the model, for example. I can save the content filter configuration, and now this is the content filter that is being applied. Okay, and with this, we are getting to the end of this demo. Wow, we have finished session 3. We have learned how to plan a responsible generative AI solution, identifying, measuring, and mitigating potential harms, and finally, how to operate a responsible generative AI solution. This concludes our Microsoft Azure Virtual Training Day, Generative AI Fundamentals. Let's recap what we have learned. In the first session, we have explored the fundamentals of generative AI, explaining what large language models are and how do they work, and also the different tools available at Microsoft, like Copilots, for example. In the second session, we got into the Azure OpenAI service and the models inside. And finally, we have learned how to plan a responsible generative AI solution. This concludes session 3. Thank you so much for your time.